Thank you for joining this lesson. We're going to do Trigonometry 3, whereby we're going to consider the Maranda mock of 2021, number 6, paper 2. So we are taught to solve the equation 5 cosine squared of theta plus 2 equals to 3 sine squared theta minus 2 cosine of theta for the range 0 degrees up to 360 degrees. Remember to subscribe to this channel and to also share the link with your friends. So we're going to evaluate this question, and most importantly, we should remember the identities of trigonometry. The one which says that the cosine squared of an angle plus the sine squared of an angle equals to 1 should lead us to concluding that the cosine or the sine, squared of an angle equals to 1 minus the cosine squared of an angle when we take cosine to the other side, so that we remain with sine squared on one side. So now, instead of sine squared theta, then we can substitute it with 1 minus the cosine squared of theta. So we can rewrite this equation starting with 5 cosine squared of theta plus 2 equals to 3. Instead of sine squared theta, we have 1 minus the cosine squared of theta, then minus 2 cosine of theta. Okay, now we can open brackets and group like terms together. We remain with 5, the cosine of theta squared, plus 2 equals to 3, minus 3 cosine squared of theta minus 2 cosine of theta. Therefore, we can rearrange these equations so that we remain with 0 on one side. And this can be done by having cosine squared of theta be brought here. This is 3 negative. It becomes positive to this side. And we'll have 8, the cosine squared of theta. Then this one becomes positive 2, the cosine of theta. So this one has been brought to this side. This one has also been sorted. What is remaining is 3. It becomes a negative. So 2 minus 3 will give us a negative 1 equals to 0. Equals to 0. Therefore now we can let the cosine of theta to be, let's say, y, so that this becomes 8y squared plus 2y minus 1 equals to 0, and we solve it quadratically, whereby we can use a factorization method, product negative 8 and sum 2. This can be negative 4 and positive 4 and negative 2. When added, they will give us positive 2, and when multiplied, negative 8. Therefore, now we can substitute 2y with 4 and negative 2. And this is going to give us 8y squared plus 4y minus 2y minus 1 equals to 0. Therefore, in the first bracket, in the first two terms, we can factor out 4y to remain with 2y plus 1. Then we subtract 1 so that we remain with 2y plus 1 equals to 0. 2y plus 1 equals to 0. So this, we can now say 4y minus 1 and 2y plus 1 equal to 0, so that we can equate this one to 0 and this one also to 0. And we shall have y equals to a quarter, because when we take 1 to the other side, it will become positive when we divide by 4, or y equals to negative half. It is important to remember that we had let the cosine of theta to be y. So the cosine of theta can either be a quarter, or the cosine of theta can be negative half. So we can take these angles which give us these cosines, and theta will be the cosine inverse of a quarter. So the cosine inverse of a quarter is 75.52. And also theta 2 can be the cosine inverse of half. Though it's negative, we first of all get cos inverse of half, which is 60. But now we want 60 where cosines are negative. And according to the unit circle, we have cosines being negative in the second and in the third quadrant. Therefore, this means that 60 degrees in the second quadrant is 120, and 60 degrees in the third quadrant is 240. So we have those three angles now. In case we go for another cycle, the first angle here, which is 75.52, will become 435, which means it will have gone beyond the range or beyond the limit. But again, because it is 75.52 and the cosine is positive, then we can have another angle in a different quadrant where cosines are positive. Therefore, 75 degrees in the third quadrant will be 360 minus 75.52, and this will give us 284. So another angle which is similar to 75.52 is 284.48 degrees. So these are the four possible values of angle theta. Thank you for following. Subscribe and share.